Hello and welcome to 8.3 Notes. So in previous sections, we were given a parallelogram and we used theorems 8.3 and 8.4 to prove statements about the angles and the sides of the parallelogram. So given a parallelogram, hey, this is what you could say about the angles and the sides. Well, today we're going to do the converses of theorems 8.3 and 8.4. In other words, the converses are also true. So we can use theorems 8.3 and 8.4 and other theorems in this lesson to prove that a quadrilateral with certain properties is a parallelogram. So it's kind of the converse of what we've been doing in the past. So in other words, before we had theorems that said if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent, right? Well, today we're going to do the converse of that. We're going to say if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is or must be a parallelogram. So if you have this quadrilateral and you have AB is congruent with CD, and you have BC is congruent to AD, then the figure here, ABCD, must be or is a parallelogram. So that's what we're going to be doing in today's lesson. Another one of these theorems that could be used to show that a quadrilateral is a parallelogram is if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. It must be a parallelogram. So if you have angle A is congruent with angle C, and angle B is congruent with angle D, the only way that can happen is if the figure ABCD is a parallelogram. Okay? And then moving right along, if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram, or must be a parallelogram. So if you have this figure, and we're only concerned with one pair of opposite sides, in this case BC and AD, okay, just one pair of opposite sides. We don't really know or care about the other two pairs of opposite sides, okay? So if we can say that this one pair, BC, is parallel with AD, and that's what the chevrons mean, right? They're parallel. And if we could say that the same pair of opposite sides are congruent, and again, that's what the black tick marks mean, they're congruent, then the only way that can possibly be the case is if the figure ABCD is a parallelogram. So it must be a parallelogram. And then finally, the last one, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram or must be a parallelogram. So you have this figure, and BD is one of the diagonals, and AC is the other. If they bisect each other, and that's what these tick marks are showing, they're showing that they bisect each other, then the quadrilateral is a parallelogram. Okay? And remember, at any point you can pause this presentation and take notes or review it, or anything you'd like to do. Remember, you're in total control of this presentation. But these are the four theorems that you're going to learn today. The four different theorems that you would use to prove that a quadrilateral is a parallelogram. And what I've done for your convenience is I took a picture of the concept summary for your notebook. It has all of this on one page. So this is basically the whole entire lecture. If this is all the ways that you would use to prove that a quadrilateral is a parallelogram. So really quickly, just a quick summary. One is based on the definition of a parallelogram, which is that you would need to show that both pairs of opposite sides are parallel. Or you can use theorem 8.7, which we just went over, show both pairs of opposite sides are congruent. Or Theorem 8.8, show both pairs of opposite angles are congruent. Or Theorem 8.9, show one pair of opposite sides are congruent and parallel. And then finally, 8.10, show that the diagonals bisect each other. So again, like I said, these are the 5 ways that you would use to prove a quadrilateral is a parallelogram, and you would need to know how to use these different techniques to prove that a quadrilateral is a parallelogram. So you'll be responsible for that. I'm sorry if you can't see this very well. I tried my best to take a picture of it. As you may remember, it's very difficult for the iPad to take pictures of a font that is too small. So if you can't see this, like I said, I do apologize, but you can go on page 525, and the concept summary is on page 525. So you can just go on page 525 of your textbook and copy these down, but you will be responsible for knowing these 5 theorems and definitions. Okay. How will these problems be used? Okay, you'll have problems like this. What theorem can you use to show that the quadrilateral is a parallelogram? So I have this figure, and I want to show that it's a parallelogram. So let me see. Looks like they're only talking about one pair of opposite sides. I don't know anything about this other pair of opposite sides. And what are they telling me about this one pair? Well, they're saying that they're congruent because it's 30 meters and 30 meters. And they're saying that they're parallel because of the 2 chevrons. So I have one pair of opposite sides being congruent and parallel. So I'd go back and I go, oh, one pair of opposite sides are congruent and parallel. That's Theorem 8.9. So it must be Theorem 8.9. Okay. And then this quadrilateral, I need to prove it's a parallelogram. Well, I'm noticing that they're telling me that this pair of opposite sides are congruent, and also this pair of opposite sides are congruent. So it seems like both pairs of opposite sides are congruent. And then if I go back to this, both pairs of opposite sides are congruent. Ah, it must be that one. It must be Theorem 8.7. Okay? So the answer to this is Theorem 8.7. And finally, we have this figure, this quadrilateral, and I see that I have an opposite pair of angles are congruent, and this opposite pair of angles are congruent. And so we have show both pairs, these are both pairs of opposite angles are congruent, right? This is congruent with that, excuse me, and this is congruent with that. And if you look back on the sheet here, I think that would be Theorem 8.8, right? Yes, Theorem 8.8, showing both pairs of opposite angles are congruent. So that's congruent with that, and that's congruent with that. And so it would be Theorem 8.8. Okay? Theorem 8.8. So those are the types of problems that you'll be getting. You'll need to show that a certain quadrilateral, given certain features of its sides or its angles, you need to show that that quadrilateral is a parallelogram. Okay, so that's the end of the notes. And if you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay, bye-bye.